the HVO, and we're going to do a little demo of the ASIAIR. This will be if you have your own ASIAIR, or if you're here trying to run the HVO with some assistance, you'll get some kind of familiarity with it. So the first step to do this thing is to, of course, get into the app and get that going. We come down to the tablet and there's the ASIAIR icon. We tap on that. And it says enter device, and we tap on that. And it's going to search for the ASIAIR, and when it finds it, it'll come up and app is running, so we just say connect. And so here you get the your position, the latitude and the longitude. This is some useful information. You should always go over this. At the top it tells you the mount. There's also a drop down. You can choose a different mount depending. You have your main scope focal length in millimeters. For the HVO it's 3127, and then the guide scope is 1250. That is our Bahtinov SkyMax 90. And our main camera is the ASIAIR 2400 Color Cam Pro, and our guide cam is as well ASI 174mm Cool that we bought with our first grant money, and it used to be our imaging cam, but now it is our guide cam. So once all that looks good, you go ahead and hit enter. And so now it brings us to this screen. And the first thing you want to do is make sure you got the dust cover taken off, because that's something that is going to interfere with your captures. So you want to get focused first. You want to check your focus. There's a couple of ways to do that. The ASIAIR has an algorithm over here. We'll go over here, and it's called focus, obviously, and that's where we're in focus. And then here you could choose the exposures. You can go 1 second, touch on that thing, and then you can just scroll it up with your finger, up or down, shorter, whatever, pick. And depending on your optics, you might need longer or you might need shorter, depending on the filter you have. Here we are at around 2 seconds. Now, the scope is facing north, and it's in a parked position here facing north, so we're going to just do a quick capture here of 2 seconds and see what it looks like. Now, focus is important because if you're not in focus, it'll have a difficult time plate solving, and it's not showing any stars right now. So another way to do it, if you don't see anything there, is just, of course, increase it to 5 seconds. Now sometimes it's because you're out of focus, and so the stars are not sharp. So what I try to do to make sure, this gives us a narrow view of the chip. You're not seeing the whole thing. So I'm going to stop this because I'm not seeing any stars whatsoever. So I'm going to come over to where it says preview. Now with the preview, we'll get the whole chip. So let's do let's do a 5 second exposure and see if there's any stars at all. Looks like it's dark enough to show something. Okay, see, so we got a couple of 3 stars in there. So what I wind up doing, I find the easiest method, there is an algorithm that will focus this for you. If you're at the HVO, or if you have a Bahtinov mask at home, I find that really gets it done pretty quick and eliminates a lot of the guesswork, and especially when you're starting out and you're looking at numbers and you don't know if that's right or that's wrong. It's old school, but it works real good. Developed by this Russian guy. Anyway, this is it here. It has a hole in it in order to go through the secondary housing. So now what that'll do, that'll create a diffraction spike pattern. When it's perfectly symmetrical, you know your focus. So we're going to take another exposure, leave it right where it is. We've got a star there that's a little bit below the center and below center. And that should get into like a pattern, like, you know, you see like a diffraction spike of sorts. So let's see what we got. Okay, so now we'll zoom in on this little guy, and apparently it's not enough exposure. So we're going to have to go, it's either that or you could slew to a brighter star. But I'm just going to go ahead and give it a 30-second exposure. It should be brighter with 30 seconds, and maybe we'll get to see some kind of pattern. The way this scope will find its way around the sky is plate solve. So basically it takes pictures, analyzes them against a catalog, and determines where it is, so that when you ask for a target, it knows precisely where it is, at least to a high degree. And then when it goes to the target, it will photograph it again, and then see how close it got to the target, until finally the plate solve says that the target's dead center. Okay, so with that 30-second exposure, you can see we're getting a little more diffraction spikes, but it's still not quite that good. So we're going to move on to a brighter star. We'll be right back. Okay, so we decided to choose Vega, which is directly above us. Hopefully we'll get it. We moved the dome, so the next thing, in order to get to Vega, we'll plate solve our way there. Make sure you take this off, because your stars will be all spiky, and then it won't plate solve well. Okay, so the way to do that would be to come to your sky map, and it will show you where it's currently at. And then you can do there's a couple of ways you can do it. You can zoom back like that, okay, and then just look for Vega. It should be somewhere in zenith. There's Denham. Oh man, that is like straight up. I don't know if we'll be able to get it. Might not. You can use the map, and you can see it tells you it's pretty close to zenith. It hasn't crossed the meridian, I don't think. And so what you do is you zoom in. Okay, click on it, and then over here it says go to. So I'm going to hit go to and mount slews to target position. And so now the scope will slew to Vega, and it will plate solve and get us on target. And that should be bright enough in order for us to use the Bahtinov mask. Getting there. Yep, just barely made it. So now if you look at the tablet here, that's our chip, that blue square, and that's its position. Currently, it's taking a picture to see where it is. It found 293 stars to compare it in the catalog, and it will probably make a little slight adjustment until it gets it there. Now this is pretty much the procedure that you're going to have when you go to targets. You'll look for the target in the catalog or type it in the search bar, and when it comes up you'll say go to, and now according to the app, we're on target. The target is centered. So now with that, we'll go back up here in the upper left-hand corner. There's an arrow, and that puts us back to the main screen. See, with Vega, I'm sure we can do much shorter than that, which should save us some time, and take a 2-second exposure. Okay, now that's our screen. So now up here is in the upper center, I believe that's Vega, although to tell you the truth, that looks pretty dim to be Vega, but it looks like we might be a little out of focus. So that star is bright enough for us to use the Bahtinov mask, so we'll put that on it. Again, you can use the algorithm, but I'm trying to make this real super simple, and that's about the easiest way to focus any telescope. So we'll do a 2-second exposure, and that star in the upper center there should have a diffraction spike on it created by the Bahtinov mask, in theory. So and we'll get a peek. Looks like it might not be too bad. There it is. Actually, guys, we'll zoom in. That's pretty daggone good. Now you see that diffraction spike there? That's pretty good. You could sweeten it up just a smidgen. You can make it go to the left a little bit, but I'll tell you what, that's good enough, especially for a mirror. So we're in focus with the filter that's in there. Because when you change a filter, you have to check your focus again. Don't forget to take the Bahtinov mask out. That's a common mistake. We've all done it. So now that that is done, we have that. The next procedure would be to shoot a flat frame. Now, if you're out here starting out and it's not for keepers and you're just like doing a, just a night to where you're just trying to show people stuff in the sky, then you necessarily wouldn't need a flat frame. The flat, what it does is it takes all the optical imperfections out of the imaging train and cancels them and subtracts them out when it's doing a live stack. And that's what it's for. And if you're going to calibrate the images, if you're doing this for yourself with your own air, then you want the flats and the darks and the bias. So you'll add those things in when you do your calibration, which means you clean up the images with these frames. These frames take out the imperfections that are inherent with the system. And so that's what you would do. At the HVO, to shoot a flat, the way we do it, let's see if I can get this to, let me change the rate. Okay. So now I'm using the keypad here on the tablet to move the scope in a position to where I could get the flat opaque surface on the objective and then put a light source on it to subtract the imperfections. It will highlight them. You'll see here in a minute. Again, you can operate this mount with the tablet. I'm just holding that up and down arrows, those four-way arrows. Now I want to get it over towards where the light is, which is in front of me. And that's probably good. And then we'll turn this the other way. And about like that. Okay, so now we'll take the flat panel that we have here. It's just a simple piece of paper that's been stretched, and it has some screws so that it can hang off the dew shield here, or what that is. So that creates a smooth surface. So to do the flat, we come over to where it says live, and you tap on that, and then there's the hamburger beneath live. Tap on the hamburger, choose flat, choose 20, and make sure that the exposure says auto. So it's going to figure out how long the thing should shoot. So you say okay, then we're going to take our light and just hold it like that and start it. Just hold it like that. You don't want it too close. You want it evenly lit is what you want. And now it's calculating the exposure on what it needs to do. It's already stacked two of them, and we told it to shoot 20. That's the maximum. Now if you look at the image there in the lower right hand corner, you see those dust donuts. I'll also see a dust donut if you come up a little higher from that lower one and off to the left. You'll see a large dust donut and another one up at the top. Also in the corner there's dust donuts in the upper right, and there's vignetting as well. So all of that's going to be subtracted when we use this calibration flat for our stack. And that will apply to the live stack or to the, if you take this data at home and you use Cyril or PixInsight, then you'll be able to use these flat frames. Depending on your optical system and how you handle your telescope in your environment, you might have to shoot flats every night. If you break down at the end of the evening and remove your camera or change anything with the imaging train, focus or what have you, then you'll have to reshoot your flats. Now focus, if you happen to just barely move your focus in or out a little bit, you know, then it's not really going to be that important. But if you change your filter or your imaging train setup, then you're going to want to do it. So here it says it's stacked it for us. The ASIAIR is wonderful for shooting flats. There are other ways to shoot flats, but I really like the ASIAIR for shooting flats. And again, now you can see the imperfections in this flat frame, how it's shaded darker to the right and brighter in the center, and then it's also darker to the left in the upper left-hand corner. So now that we got our flat frame, remove the flat screen. And come over to the hamburger again. And now what we're going to do, we're going to click on lights. In other words, these are going to be for the images that we're going to be using. This is for binning, 1 by 1, 2 by 2, 3 by 3, 4 by 4. We're going to use 2 by 2. Now binning, what it does is it takes two photo sites or pixels on the chip and combines them as one through software. Okay, because this is a CMOS camera. Only CCDs actually physically can combine them physically, whereas this is done through software. I'm not going to get into the technical aspect of that. It's not necessary for this demonstration. Because of the long focal length, we bin it 2 by 2. Because if we did it 1 by 1, the resolution would be oversampling. We would be taking too much detail that the optics and the sky really can't support. So we do a 2 by 2. It also makes it to where the scope becomes a little more sensitive to light. Now, here you see save every frame when stacking. You could check that if you want, or you can uncheck it and then it will only save the final stack. For the HVO, I find that just the final stack is all we ever really need, because very few people are taking this stuff home. So I uncheck that, and that saves memory. So we want to have a stack duration, no limit. That means take as many until we tell you to stop. Okay, and so we're going to say we want to do a flat frame, and we want to select that flat frame, and that would be this one right here, this latest one on the top. So we select, and then the darks. We're doing 180-second dark, so make sure your exposures match your dark frames. 180 seconds seems to be the sweet spot for this. These days, with satellites and all this other nonsense, it becomes difficult. You wind up losing a lot of subs if you get past 5 minutes with a satellite or what have you. So 180 seconds for 12 inches of aperture seems to work pretty good here. Now, the next thing is we want our bias frames. The dark frames are frames that are taken with the sensor covered at the same exposure that your light frames or your capture frames are going to be. That will generate inherent noise that will be subtracted in the final image as it stacks. The bias frames is about the same kind of thing. These are electronic interferences, you might call them, that are taken out of the frame. So once you select that, then you say OK, and it says change settings, and you say OK. It asks you because we changed the flat frame from what it was before. Now that that's done, and you have the cover off your guide scope, let's get this off. Okay, cover off the mock. Now we're ready to have a little bit of fun. So we'll come over here to the map, and what I like to do is just kind of, well, if you know the target you want, then you could just go ahead and type it in up here. It says objects, so you can, if you go to the lower left, click on objects, and this is for my favorites, which we don't have tonight. Let's see. My favorites, tonight's best. It gives you a list of objects that it considers the best objects for this evening. Lots of ways you can do this, and it just depends on what your intentions are. So for tonight, we're just going to do one. We're not going to do them all for this demo. Also, if you look at the graph here on these targets, this shows you, like, look at the Triangulum Galaxy. It's under 45 degrees in altitude. Where you see the peak is, that's when it's the highest in the sky. And usually that's the best time to image because you're looking through less atmosphere. As it's lower, you're looking through more layers of atmosphere, and it's not optimal for getting the best data. But again, depending on what your goal is, you can choose whatever. Now the Pelican Nebula, according to this, is almost at zenith, and that's a pretty nice target. Let's see, keep coming up here. The Butterfly Nebula, the Jellyfish is not up yet, and the Butterfly is at zenith. That would be in Cygnus. It's actually in the center of Cygnus. Let's see, trying to get a galaxy here, guys. Can't believe they don't have galaxies. The Pleiades. The Sculptor Galaxy is too low. So another thing, if you look over here in the upper right hand corner, there is a funnel, and with that you can tell it that you don't want anything less than, let's say, 40 degrees. Okay, so it has to be 40 degrees above the horizon or it won't show it. So we'll say OK, and now it refreshed. So all these targets are at least 40 degrees above the horizon. And the Fireworks Galaxy is close to zenith, which is going to be hard here at the HVO, imaging at zenith. The Phantom Galaxy is kind of low. The Deerlick group, NGC 7331, that's an interesting galaxy. That galaxy, it's actually rotating in two different directions. The outer part of the galaxy is rotating one way, and the inner part of the galaxy is rotating another way. I'm not sure whether they figured that out yet. Why? Because it is an anomaly. But let's go there, because it also has other galaxies associated with it. And it looks like it's above 45 degrees alt, so it should make a nice target. So to do that, we just click on it. And then over here on the right-hand side, you can just click Go To. Now I'm going to have to move the dome because I'm up here on my own and see where it takes us. So let's see if that, yeah, not too bad, a little bit more. Okay, try that. So it's going to shoot and then center up, just like it did when we went to Vega. It's detected 366 stars, which is good for a plate saw. And there it is. So it's on it. Yeah, that easy. The next thing to do is to get your guiding going. So we want to get back to the capture side of this thing. Again, upper right-hand corner, there's an arrow. Upper left-hand corner, there's an arrow. And let's do guiding. So we come over here to the left side, and it says guide. And tap on that. So you hit this circle thing so that it will start to cycle. It's a 3-second exposure, and now you hit the bullseye, and then it finds the stars, and that's the profile of the star, and it will start to guide. Because without guiding, when you do the 3-minute exposure, you're going to have movement. The tracking is not going to be up with the actual movement of the Earth in relationship to the mount's movement. So this will help keep it centered on the target. So now that that's done, if you go to the upper left hand, you'll see two arrows touching each other. Click on that, come to the live stack, and we're already set up. Our exposures are for 180. Remember, our darks are 180 second darks, so that's going to match with our light frames. So we're going to say OK, and then you hit the button and let the magic begin. And after 180 seconds, it will start to give us an image one at a time, and it's going to live stack them, and that will allow us to save that and show it later on. Be sure, while I'm talking about live stacking, be sure before you quit your session, if you look at the capture tab over to the right where it says live, you got the hamburger, and then you got the progress, you got a little broom, and then down there you got an arrow. That is to download the image, the stack, before you change objects or before you shut her down. If you do not save that stack, you won't have it. It doesn't save it automatically. You have to save it physically at the end of each session. Unless you're saving your individual subs, if you're doing that at home, if you're imaging for yourself, I highly recommend saving those subs because you'll get better results by putting it in Searle or PixInsight. When you're doing outreach, however, like at the HVO or wherever we go, you don't really need to save it unless you want to. Because outreach, you're just doing like what, 10, 15, 20 minute total integration on whatever particular target you're looking at, and then you're hopping on to the next object of interest. And so it's not important to have it because, you know, these are just like, you know, onesie twosies. It doesn't really matter. So we got 81 seconds into this 180 second sub. If you look over to the graph on the upper left hand side, that is your error in right ascension and declination. The total is 0.86, not bad. We're under an arc second of error. That's pretty good, especially for this package, as big as this monster is. So we should be okay. We should be okay. I'm not sure of our imaging scale, but I think it's right around 1 arc second or so. So we should be fine. And again, if this is outreach, it doesn't have to be perfect. Don't, you know, pull the hair out of your head, if you have any, for trying to get it absolutely perfect. Outreach is just to show the public what's going on. So in some ways, this is a lot like the C-Star that Jim gave a demo of last meeting. The main difference between the AIR and the C-Star is you have a lot more choices in terms of equipment. Different mounts, different scopes, different guide scopes, just a lot more. Plus, you could do longer exposures because this mount is in equatorial, whereas the C-Star runs in alt-az, which limits how long it can do an exposure. Usually no more than about 10 seconds or something, because then you start getting field rotation. You need to be on an equatorial mount to do like 3 and 4 and 5 minute exposures, which is great, especially if you're doing narrowband imaging. Okay, so here we got the NGC 7331 right there in the center there, and that's only one 180 second exposure. Now that galaxy has a lot of dust lanes around it, and it's a pretty interesting galaxy. I also see several other galaxies around it. They're elliptical. They look like fuzzy stars is what they look like. And if we give this time, it will start to give us more and more detail. That's the beauty about the live stack. So if you're doing outreach, within just 3 minutes, you got something to show people. And as time goes on, it will start getting more definition and more resolution.
Got 4 180 second subs here, and over here on the left hand side you'll see what it says histogram. This is your histogram. Pull that up and then hit zoom, and this will allow us to manipulate that, bring it out a little bit more, to see if we can. That makes it a little brighter. Let's bring this in a little bit like that, darken up the field there. And now we're not obviously going to keep it this way, but sometimes it helps if you're looking to see what's potentially out there. Now, we do it all the way over here, and you look above the deer lick, you could see some of the dust lane that is up above it and below it and to the left and to the right. So that's what's going to start showing up once we get our, we get enough data stacked up. And that's brightening the core. We pull it back, and that darkens it up. And you can see those two ellipticals now a little bit better right there. But see, you could see those dark dust lane. That there's a one that's in the close to the center and arcs around there. If you look, we can also zoom in, and it gives you an idea. So once you get playing with that and you got it all messed up, then go ahead and hit auto, and it puts it back to auto. And then you can get out of the histogram by clicking it again, and now you're back to the screen.
Okay, so here's a stack. We have 14 images, 42 minutes, just under 3/4 of an hour. And if you wanted more detail, of course you would go longer, but being that this is just a demo, we're just showing, 42 minutes is enough on this target. And that's it there. NGC 7331, the Deerlick Group. So I hope that you found this video useful, and get out there and image, guys. Take care. See you on the next one.